Alright, my name is Evan and welcome to my SkySphere tutorial. In this tutorial, I'm going to teach you how to make this procedural sky shader that I have right here that can be animated using material parameter collections to create a day and night cycle either in UE5 or UEFN. And this material that we're doing comes with a horizon, an atmosphere, as well as stars and background clouds, as you can see right there, and it's all procedural. We're using no textures for this sky material, which is super awesome, especially for something like UEFN where you have a small upload limit like 400 megabytes. Having procedural shaders like this is huge and saves you a lot of space. So let's get right into it. Let's go into the nodes. So I'm gonna click on the sphere, procedural sky. Let's open it up and let's make this window smaller so you can see all these nodes. Alright, so first I'm just going to go through all the nodes. For anyone who just wants to copy the nodes, here you go, just take screenshots from me going through like this, okay? So we have a sky gradient right here, and we make a gradient for the two colors, and then what we're doing is we are doing alert between the two colors using the sky gradient and blending those two together. Over here is the blend chain where we take our stars, sky, and clouds and blend them all together and composite them on top of each other. And then right here we have a cutoff below 0Z so that the sky sphere is not being emissive below 0. Otherwise sometimes it can look weird. And then in our cloud section we're doing a whole lot here, but we're basically using a 3D noise texture to have 2D clouds projected, and then we're using the third dimension to evolve the clouds over time. And here's another cloud mask. This is just a linear gradient like the sky one before. And as far as these star nodes, it's in a material function. I'll go through it real quick if you want to copy it. Here's the places, but my challenge to you is to learn through this tutorial where I learned it from, called procedural star fields. I learned a lot about textures and procedural noise and all that from this, and it's a great tutorial, and I'll put the link in the description. Anyways, back to the material. The two important things for you to have on your material settings is for it to be unlit, as well as type is sky in here and check is sky yes. That's so that when we have a skylight in our scene and you click real-time capture, it's taking the sky sphere that you have and using that for the emissive skylight. Super important right there. Is sky as well as real-time capture is what you need. And now I'm going to widen this window here so I can show you what all the parts of this shader do and how it works. So I have this test out named reroute node. If you don't know about named reroutes, I have a tutorial on them. They're super awesome. And what we're going to do is plug it into emissive color. And so then just whatever we plug in, this too is going to preview for us. So our first linear gradient right here, to make a linear gradient, you take a value and of like world position, we're taking the Z value. So it's going to change as we go up. And then we have our offset, which we add to that value. And then we divide by the scale. And as you can see, I have a multiply by 1,000,000 for each of these collection parameters. And that's just because when you have a sky, the scale values get really big. And in my material parameter collection, it's a lot easier to work with values of like 1 and 2.2 for these values for the offset, like 1.6 and 2 right here, versus having to put it into the millions. So just a little multiply to make the numbers more usable for us. If you don't know how to bring in collection parameters, just type collection parameter. For the collection, you choose which MPC you're doing, and you can create one there too. And then you choose the parameter that you want. And for this tutorial, we have 3 different material parameter collections. We have clouds, sky, and weather. And we split these up because when you're animating things through the sequencer, sometimes the sequencer can get confused if you have like multiple sequences on top of each other. So just splitting them up makes things a lot more workable, and you'll have less bugs. So anyways, we plug this into the test out so we can now see the linear gradient that we have. And in these subsequences that I have on top of each other, I have one for time and one for weather, and then we just combine the two. You can see that this gradient throughout the day is going all over the place and changing its scale and offset. And if we just go back to the normal color, now you can see that that's what controls where the 2 different sky colors are going to be at that point in the day. Anyways, going back to our test, What we then do is we take this sky gradient value, which we put into a reroute, and then put it into an alpha of the lerp between our two colors, and that's how we get that nice mix. And then we can put this into sky out, which is going to go into our blend chain later. Going to the clouds, what we do is for our UVs, basically, we're taking the reflection vector and then we're inverting it. At first, I have world position, but I can show you what world position looks like if I use that. If you plug world position into here, I think you need to normalize it too, actually. It looks decent. This is what I was using for a while. You'll get these clouds in the sky, but as you can see, they kind of warp as you look around, and they go all the way down, which clouds don't really look like. So when we get this reflection vector instead and plug it in here, we get a nice projection of these clouds onto the sphere instead, because that's what the reflection vector does. And they just look a lot more three-dimensional like this. And when they move across the sky, it looks a lot better as well. So then what we do to actually move them across the sky is we're going to take the reflection vector, break it into 3 components, x, y, and z over here. And then what we have is all these parameters for cloud x speed, cloud y speed, cloud z speed. All of these are multiplied by time, and then what we do is we just add it to the original one. So we're adding an offset to it, and then we put our coordinates back together into a float 3. Divide it by a scale parameter. You can see what this does if I change the scale. And clouds, let's go to weather. If I change the cloud scale, either makes them smaller or bigger. Super nice parameter to have. And then we're just plugging that into the world position of this noise. And this noise is set to 3D texture so that we have both an X, Y, and Z. And so what we do with these is cloud X, Y, and Z speed are all different values, and that controls them going across the sky. And I'm going to close out of the sequencer real quick. All right, so if we go into nighttime, we can see these clouds better, and then I can show you what happens if I up the speed. X puts it to the right, right? Y puts it in that direction. And then if I put these back to normal, which is a pretty small value just so it looks smooth, then you can see when I change the Y speed is how we evolve the clouds over time, how we just change their shape. And this looks pretty close to real clouds, just sped up in real time, which I really like how it turned out, and it's all procedural using this noise. So let me put this back to a normal value, and then I'm gonna keep going on these nodes. So what we then do is we take this noise and we're gonna have a dither, which if you don't know what dither is, it's a really big topic, but super useful for shaders just to make things blend in and make them kind of half opaque by poking holes in it basically. So what we do is we have the dithered version and then we have the normal version. So I'll show you the normal version, just looks like this. Which is obviously, these don't look a lot like clouds, they're not blended into the background at all. But if we take the dithered version, which looks like this, and then we lerp them together, we get a good mix of opacity in the middle and dither around the outside, which I really like how it looks like. I think that looks like how clouds actually are. And you can change the cloud dither amount as much as you want. Then we're multiplying by our cloud mask, which is just another linear gradient that we have and that we can animate. This is just like the sky gradient that we have above. We're just putting it in a different spot. So you can have the clouds in the sky animate differently over time. And then we are going to use cloud contrast using a power node. Pretty simple here. What this does is change the contrast of those clouds. So it's good in small amount, like adjusting small amounts, pretty subtle effect. Otherwise, it can get things kind of messed up. Then we're multiplying by the cloud color. Again, we take our sky gradient and then we're going to lerp between. This is just like what we did with the sky, where we have a top color and bottom color, and then we just use the gradient to figure out where those colors go. And the last multiply for the clouds is cloud intensity. And then we can output our clouds. And if I put this into test out, then if we plug the test nodes in, like this, we can see just our clouds, and then you can work with just your clouds if you want and change all the values in your sequence. So over time, these clouds are constantly changing. the way that they move and where they are in the sky. And so the last thing to go over is this blend chain. Basically, we just go from what's in the back to what's in the front, right? So stars are furthest back, then we have the sky, and we're just adding these on top of each other, simple blend, and then we're adding the clouds on top of the sky because the cloud's in front of the sky. Then the last multiplying we do is this cutoff blend, and then just overall combined brightness parameter. And then there you have it. You have your procedural sky. This is great for taking the graphical fidelity of any UEFN maps to the next level. And in UE5, you can just use these as background clouds on the sky sphere and then put volumetric clouds on top of it. And it looks really, really good, especially when animated over time. And if you want to animate this, the way that you do it is just by making sequences. And in the time cycle, I have brought in, you click add, and then you can bring in material parameter collection track. So you just do whatever material parameter collection you want. And then when you click the plus, you can go through all the different parameters and just animate them with keyframes over time. So I just made a full day sequence that's 10 minutes long, and I just set where the different times of day were, and I basically went through and made sure each time of the day is looking good and the transitions are good. And if you want this exact sequence, I'm going to sell this project file for $10 on Patreon. And then in the next few weeks / month, I'm going to make an actual fab asset for this sky sphere that you'll be able to buy for $10 to $20. So thank you for watching. I hope you learned something from this tutorial and you can use this in your projects. If you have any questions, leave them in the comments.